So if you go to the next page in your packet, which at the top says changing a complex number from trig form to standard form, that's the page that we're going to start on, which is page 6, I believe, in your packet. Down there at the bottom of that one, later on, we're going to want to change z sub 1 and z sub 2 into trig form. So those are the two warm-ups that I'm actually going to go with today. So if you could convert at the bottom of that page 6, down there in part B, if you could convert those two, both of them, into trig form right now, that would be a great warm-up. Go for it. So you should have gotten that. Z sub 1 is 5 cosine of 53.13 degrees plus I sine 53.13 degrees. And Z sub 2 is 13 CIS 292.62 degrees. Anybody not get that or need explanation of it? Here we go, takers. Okay. We'll come back to those here in a minute. Okay. All right. So yesterday in class, what we did is we started with a complex number in standard form. Then we put it in ordered pair form. Then we put it into trig form. Today, we're going to have an ordered or a complex number in ordered pair form, in trig form. We're going to put it back into standard form so that if we needed to put it into ordered pair form in the complex plane. Okay? And it's very easy to do. You just simply distribute in that R value into both of those things. Now you can do this in one of two ways. The first way is you could literally just figure out what 8 times the cosine of 135 degrees is. Anybody? 8 cosines, 135 degrees. Negative 5.567, right? 656. 6.5. Yep, 6.57. That's what it was. I knew there was a 5. I knew it was 5, 6, and 7. Huh? And that works. Works for it. Easy. It's the first method. Do I like it? Kinda, maybe, a little bit. If it's not on the unit circle, it's my only option. But if the angle that you're dealing with is on the unit circle, then we can be exact with it. So we could say here that 8 times the cosine of 135 plus 8I sines of 135. Well, what is the cosine of 135 degrees off the unit circle? Cosine 135 degrees off the unit circle. Negative root 2 over 2. Sine at 180 or 135 degrees. Square root 2 over 2. Trust me, guys, class will go a lot smoother if you participate. Okay? I'm never going to give you an answer that I don't think you know the answer to, or give you a question that you don't know the answer to. 8 divided by 2. 4. Okay? So this first one simplifies to be negative 4 square roots of 2 plus 4I square root of 2. And these two are the same. The top one is just rounded. The bottom one is exact. If your angle is on the unit circle, exact. You don't get a choice. If your angle is not on the unit circle, you get to round. And we'll tell you what to round. Okay? With that being said, you now try that one. 3 pi over 2 is on the unit circle. Negative 6 times the cosine of 3 pi over 2. What is the cosine of 3 pi over 2? Cosine, 3 pi over 2. 0. Negative 6 times 0. 0. Gone. Done with it. Plus I times negative 6 times the sine. What's the sine at 3 pi over 2? Negative 1. Negative 6 times negative 1. 6 times I. 6i. Now, that's an imaginary number. Okay? Technically, and I don't feel that we'll get this technical on if we take a test on this stuff. But technically, this should be 0 plus 6i if we were writing it in complex form. Okay? But again, we won't get that. Okay? That's like. So, we can do some operations with complex numbers. On the salmon colored sheet that was due yesterday for you, you did some adding and some subtracting and some multiplying and some dividing. Okay? So adding and subtracting, you add the real parts, you add the imaginary parts, move on with your life. Okay? With multiplying and dividing, we can do that like normal. So if I want to multiply these two together, 3 plus 4i times 5 minus 12i, I would double distribute, right? So I would get 3 times 5 is 15. 3 times negative 12i is negative 36i. 4i times 5 is 20i. And 4i times negative 12 is negative 48i squared. But then, what can I do? I could combine like terms, but even before that, I should do one thing. Can't get rid of the I. I can get rid of the I squared, because I squared is negative 1. So negative 48I squared is really what? Positive 48. And now I can combine both of my pairs of like terms. 15 plus 48 is how much? 63. Negative 36i plus 20i is negative 16i. Okay? What I would like you to do now is I would like you to convert 63 minus 16i into trig form. Okay? So you converting this one into trig form. What was it? Well, so in the warm-up problem, what was the angle? 292.62? So that's positive, negative, that's quadrant 4 again. I get for z sub 1, for 63 minus 16i in trig form, I get 65 CIS of 345.75 degrees. Yes? No? Maybe. Yes? Okay? You and your shoulder partner take 30 seconds. Find me the pattern. There is a pattern. I promise there is a pattern. It is staring you in the face. Like it's almost the stop. It's almost a sign pointing right at it.
Yeah, exactly that. What's that? And they would do that.
So there's actually two parts to the pattern. Give me one of the two parts. What do you got? The R's? Yep. So this number is actually R sub 1 times R sub 2. So you take the R value from the first complex number multiplied by the R value for the second complex number. You get your R value on that one. Second part of the pattern. Add the angles. The theta is theta from the first angle plus theta from the second angle. Now, what if I have three complex numbers that I'm multiplying together? Same thing. Just multiply the three R values together, add the three angles together. If I have 4, multiply the 4 R values together, add the 4 angles together. Okay? Now, the problem with that is if both of my angles are over 180 degrees, I'm going to be outside the first lap of the unit circle, right? I'm going to be outside that 0 to 360 degree range. So you have to subtract 360 until you get down in there. You should only have to subtract once if you're multiplying two things together. If you're multiplying three things together, you might have to subtract twice. Okay? And you should only have to do that once. Okay? Good times. Let's flip it around. Let's divide them. Okay? So, in division, you would have 3 plus 4i divided by 5 minus 12i. Oy, hey, these are those ugly ones where now we got to multiply by the conjugate of the denominator. The conjugate of the denominator is 5 plus 12i, and since we can only multiply by 1, it's got to be over 5 plus 12i. So now we got a double distributive on top and on the bottom. Okay? So if I'm doing the top, I'll do the top in the green. 5 times 3 is 15. 3 times 12i is 36i. 4i times 5 is 20i. 4i times 12i is 48i squared. Then I got to do the bottom. 5 times 5 is 25. 5 times 12i is 60i. Negative 12i times 5 is negative 60i. negative 12i times negative 12i is negative, or excuse me, that's positive 12i is negative 144 squared. What do I know about I squared? It's negative 1. So this is really minus 48, and this is really plus 144. So all told here, I get that this is 15 minus 48. What's that? Negative 33 plus 56i over 169. Yes? Which, written in standard form, would then be negative 33 over 169 plus 56 over 169. Now you're going to be mad at me. What do you think I want you to do with that one? Put it in trig form. Make it happen. Put it in trig form. That's where I would start. I get 5/13 CIS of 120.51 degrees. Find me the pattern. There is one. Pattern for the R should be relatively easy. What is it? You just divide it, right? R1 divided by R2?
Yeah.
Right? So in multiplication, it went multiply to get the R, add to get the theta, right? In division, it's divide to get the R. What do you think logically it would be to get the theta? Subtract. So ideally, we're going to want this to be theta 1 minus theta 2, correct? Okay, well, it doesn't look right, right? So let's look at this. So that would be 53.13 minus 292.62. That gives me 53.13 minus 292.62 gets me negative 239.49 degrees. What's wrong with that? But what's wrong?
That was at 180 degrees. That was at 360. Like when you calculated the data.
Where do I want my theta to be?
You have to double that thing and equal what those two subtract. No?
Even easier than that. If I subtract, I'm going to get more negative. Say louder. Why would I want to add 360? Now this is thinking way back to October. Where does it put me? So if I'm at negative 239 degrees, right? So here's negative 180, here's negative 239 degrees, right? I add 360. Where do I end up? The same spot, but I get a positive angle here now. So what happens when I add 360 to this? Puts it right back in my 0 to 360 range. Okay? Which is what I had said before. Remember when I said when we were adding the angles together, you might be bigger than 360 degrees? So you got to add or subtract 360 to get back in that first lap. Well, now, because we're subtracting angles, we might be negative. So we got to add 360 to get back in that first lap. We want those all in the first lap. Okay? So, with that being said, I'm going to give you 3 minutes. You shouldn't need more than 3 minutes to do this problem. Okay? Find me z sub 1 times z sub 2. Find me z sub 1 divided by z sub 2. I already gave it to you in trig form. That's why I'm only giving you thrice minutos. Go. So to multiply them, I take the r values, 6 and 3, and I multiply those together. And then I add the thetas together. So this would be in trig form, it would be 18 CIS of 270 degrees. In standard form, the cosine at 270 is 0. The sine at 270 is negative 1. So that would be the standard form of the complex number. Dividing, I take the r values and I divide them. And I take the theta values and I subtract them. That then is going to give me 2 CIS of 150 degrees. The cosine at 150 degrees is negative square root 3 over 2 times 2 would be negative square root 3. The sine value at 150 degrees is 1/2 times 2 is 1. So that would be negative root 3 plus I. Yep. Good times. These two, now, same thing. I want you to find me z sub 1 times z sub 2. I want you to find me z sub 1 divided by z sub 2. Okay? But now you got to convert. Okay? So you first got to put them in trig form first. Go for it.
No way.
That's a 30, 60, 90, because it's got same plus, the one of them's got the square root of 3. Longer one is the square root of 3, so we're going to double the short. So my R value here is 8, and my theta value would be 120. Because I'm in quadrant 2. So the trig form of z sub 1 is going to be 8 CIS of 120. Agree? Now, if you did all of your calculations and you did your inverse tangents and all that fun stuff, you'd get the same answer. Okay? It's fine. Okay? I just recognized that it was a 30, 60, 90 triangle. Okay? Likewise, in z sub 2, it is a 30, 60, 90 triangle. But this time now, we've got 1 here. We've got the square root of 3 there. So this now becomes my 60-degree angle. And my R is 2. So it's going to be 2 CIS of 60. Again, if you did all your calculations, that's fine. Should get the same answer. So, let's do these two now. Z sub 1 times Z sub 2, that would be 8 times 2 and 120 plus 60. 8 times 2 is 16. 120 plus 60 is 180. Standard form of that would be cosine at 180 degrees is -1 times 16 is -16. Sine at 180 is 0 times 16 is 0. That one gets an up. Dividing now, I divide the R values and I subtract in order the theta values. So then that is going to be 4 CIS of 60 degrees. The cosine at 60 degrees is 1/2. 1/2 times 4 is 2. The sine at 60 degrees is the square root of 3 over 2 times 4 is 2 square roots of 3. But to write it, because we have a radical, it's 2I square root. Would be the standard. Questions, comments, concerns, clarifications? Tomorrow, at the beginning of class, we are going to give you the answers to this one, which is the next one down. So for the remaining time that you have today, you're going to have 2 tasks to do. Task number 1 is you can continue to work on this so that you have this done for the start of class tomorrow when we just post the answers. That's priority number 1. Priority number 2 is I'm going to come around and I'm going to hand out for you a pink worksheet. You can do all of them on the front side of this pink worksheet. Okay? And then the back side, you can start after tomorrow. Okay? And when I do that, when I come around to hand these out, I will collect back your tests from that I just